Okay, great. You can find it anywhere, as you say. Their average rate of change of a function really requires us, so the word average here implies that we need to pick 2 points, which is a conventional thing to do whenever you're talking about change, right? What is change? Change is a comparison between 2 different things. And the kind of change, so here we're going to be picking 2 points for today. We pick 2 points on our graph. So for instance, maybe I pick this point here at 0, 0, and this point up here at 2, comma something. So I have to label the coordinates of these points here in a moment, 0, comma something. So I pick 2 points. Average is going to indicate that we're going to pick 2 points. And we're only being really pedantic about it because we're going to later talk about a different kind of rate of change that doesn't rely on picking 2 points, but instead relies on only picking a single point. That's going to be an instantaneous rate of change. That's where we begin to get a preview of what goes on in calculus. So we're going to make some inroads into that today. 1 point. But we're not really going to completely answer that story. And in fact, we can't really completely answer that story until you take a full course on calculus, because we need some of the formalisms behind limits and that kind of stuff. But for now, an average rate of change is, first of all, a comparison between 2 points on a graph. And the original graph need not be a straight line. But if we pick 2 points on that graph, and we connect those points with a straight line, then what is represented by the rate of change? Where do I find this rate in this picture? The rise over the run, which is otherwise known as slope. Exactly. So the great thing about rates of change is that they're not some brand new concept. They're just slopes coming at us in a different context, but we compute it in exactly the same way as we always had. So if I want to know the average rate of change of this function between the point where x is equal to 0, which is right here, and the point where x is equal to 2, which is right there, all I have to do is find the slope of that line segment joining these 2 points on the graph. And to find the slope of that line segment, all I need to do is measure the rise and measure the run and divide the two of them. And as usual, the rise is just a difference in the y-coordinates of these 2 points, and the run is a difference in the x-coordinates of these 2 points. So the run is usually the simpler one to do. Right? We've chosen the points x equals 0 and x equals 2, and so the run is 2 minus 0. What about the rise? Well, I need to know what the y-coordinates of these points are. How do I find out what the y-coordinate of a point on a graph whose equation I happen to know? Here's the equation for this. The graph of the function of whose graph we're looking at. How do I find the y-coordinates? Yeah. On the graph of a function, by definition, the graph of a function is a set of points where the y value is equal to the function applied to the x value. Y is equal to f of x. So every y value is just this function evaluated at the corresponding x value. So, as you say, plug in the value x equals 0. And when x equals 0, f of 0 is 12 times 0 minus 0 cubed, according to the formula for this particular function. That's 0. So that gives me the y-coordinate of our first point. And for our second point, we just use the other x value, x equals 2. F of 2 is going to be 12 times 2 minus 2 cubed. 12 times 2 is 24. 2 cubed is 8. And that gives me 16. And that gives me the y-coordinate of our second point. So now that we have the y-coordinates, we can measure the rise just by subtracting the second minus the first. That gives me a rise of 16. And now, as always, the slope is equal to the ratio of rise divided by run. 16 divided by 2, 8 in this example. So the only thing that really makes average rate of change different, a different concept than what we've already worked with when we talked about linear equations last week, is that the points that we use to compute these slopes are going to come from different points on a graph. And so to find an average rate of change, I have to tell you, or you have to select, 2 different points on a graph in order to do that. But once you select those 2 different points and you know their x values and their y values, all you have to do is then find the slope of the line segment that joins those 2 points by dividing the rise by the run.